Hello and welcome to my class. I'm Grolin Annesley from ThinkMo Education. I'm currently a Cisco Technological lecturer. If you like my video, welcome to my study group. Or contact my teaching assistant. WhatsApp account is +6 5834444290. Today's topic is IP address. In the last lesson we talked about the basic concepts of the overall network and a 7-layer reference model, including 2 key parameters in the data link layer, source MAC and destination MAC. We revolve around one of the most core parameters in the network layer today to explain to you IP address. That before we start class, let's review the main functions responsible for the network layer mentioned in the previous lesson. We mentioned the physical layer earlier. For example, a transmission medium used to connect physical devices. Finally, the connection of the device can be formed and pass the signal inside. Well, it's better at the physical layer. Data link layer. Actually both. More are responsible for the content on a link, or responsible for a function on a link. Then after reaching our network layer, we're going to open up our eyes. The network layer defines, appearing in our network worldwide, every device, every node. Its location is a global concept. The data link layer is relatively. Its pattern or scope will be smaller. That is IP address. It's like we send courier. The 2 most important parameters. That is your sender, recipient, and your address. No matter how many transfers there are, then the IP address will not be changed. We are in the 3rd floor. How to accurately find such an IP address, and how to achieve correct forwarding. This is in our network layer. The functions and responsibilities that the IP address is to provide. So our core today. It's all about IP addresses. It actually has quite a lot of content. We're going to talk about the basic components of an IP address, including its classification, and some special IP addresses. There are also 2 techniques used for IP addresses. A variable length subnet mask. One called VLAM. That is SuperNet. There is a lot of content in this class, so I hope you will listen carefully. We are now officially starting classes. I believe everyone should have heard the term IP address before. We are network engineers. You must be familiar with IP addresses. First of all, let's be clear. IP address plays a role in global positioning. This is the core of its role. Then the IP address will work in a wider range. As long as you need the network layer for data forwarding, all need an IP address. This is where it works. So for the MAC address we talked about in the last lesson, relatively speaking, its scope is smaller. It works on a link. A link refers to a logical link. For example, we have several devices connected to the same switch, without any configuration on the default switch, actually equivalent to our devices. Both work on a logical link. That is MAC address. It has a smaller scope. IP addresses provide global location. This is the difference between MAC address and IP address. I just draw a picture for you. Let's take a look together. Scope of their role in the network. For example, now this is a switch. I take what I just said, draw it for everyone. Here are the 3 PCs below. When the company is online, export to a router. So we first put these devices connected to each other. Then the working range of MAC address. Actually in this area, all devices are connected to this one switch. We call this way logical interconnection. The logical interconnection is not a real physical direct connection. There is a difference between them. For example, if you look at the difference between the two devices, PC1, PC2, data can be transferred between them. This data will be sent to the switch first. Then send it to PC2. PC1 and PC2 are logically directly connected. But they are not directly connected physically. What we call a direct connection in the physical state. Through a line. Connect PC1 and PC2 together. If their data is transmitted over such a physical link, we call it physical interconnection. But not now. Although they are not interconnected by a real wire, and made a transfer through the intermediate switch. But it's still a direct link. We call this the logical interconnection. Then the range of MAC address work has a range here. In fact, in such an area, for example, the current operator going to visit some services on the public internet in the future. This is the service provided by the operator on the public network. I also connected the router from the company's outlet. Also connected to a server on the public network. Let's say this is a Google server. Then if I pass the MAC address, want to access Google from this device, it's out of the question. Because the scope of MAC address work ends here. In the future, we will slowly start to learn the configuration. Everyone from MAC and IP will have a deeper understanding. But in the early stage, everyone must have a basic impression. The switch can use multiple network ports on the body. Connect multiple devices to one. This state is called logical interconnection. Then you need to locate a certain address on such a link. What we need to look at is a certain device. Depends on the IP address. Then if an interface of the router connected another link, such as operator, the address where we are going to work is the IP address. The MAC address no longer has the corresponding function. There is no way to cross our logical link and transmit the corresponding information. So the MAC address works in our layer 2 environment. Once the future has to cross the second floor, we have to jump out of this logical link. Can't use MAC address. Now we're going to use the IP address. That is, we have a new parameter. IP address. When data is forwarded, we are forwarding by querying IP from one device to another. For example, a return package from Google. Back on this device. The device will query the local routing table, also called IP address forwarding table. Then the data will be forwarded. After that is the MAC address and its working range. So, the two addresses are actually used in combination. It can be easily understood as MAC is to locate the local address. IP addresses, global addresses. That's in our overall data communication. IP addresses never change. The MAC address varies with the link. It will change. This is the difference between them. Here are some recaps of what came before. So let's take a look now. Other than IP address, what else we'll see today? First, there is an IPv4 address here. When I told you about the IP header before, I should have mentioned there are two versions of the entire IP protocol. One is version 4. One is version 6. We will only be exposed to version 4 during the NA phase. It is also the most used version in the corporate network now. It's also the big version we're using now. Because of the migration to IPv6. Relatively far away. IPv4 is what we will talk about today. Next. Look down. There's something called a subnet mask here. That's the core of what we're talking about today. Including a default gateway behind. In the future, when we talk about data communication across network segments, we will talk about the concept of gateway. Today we mainly talk about IPv4 and subnet masks. Some connections between them. For example, I will write you an address. 192.168.1.111. I also write the mask on it. 255.255.255.0. Let's not focus on its specific use. Remember these numbers first. I don't know if you have any knowledge about the encoding format of the computer before. Computers only understand binary when reading data. For computer, it can only recognize binary. That is, it only recognizes 010101. For example 192.168.1.1. It doesn't know these points. Then, for binary. In fact, it is convenient for the computer to process. Some students may ask, how did the 0101 pass? Since the computer can only recognize 0101. After that signal is transmitted on the current physical link. How did it become 0101? This is what each device's network card does. Such as electrical signals. We use high and low frequencies to represent 0101. Then it is converted by the network card. Finally converted to binary. Then let the device handle it. But everyone think about a question. Since it can only recognize binary, why do we now see IP addresses in this format? Because binary is not very easy for us to deal with. When we configure in the future, an IP address is a 32-bit binary number. You go to assign an IP to an interface later. Do you have to knock 0101 32 times? It's too much trouble. So, because we humans are not easy to deal with, so a decimal system was developed. So my set of numbers above. It's called decimal. Decimal means every decimal. Maybe because we grew up. I've been learning decimal. So everyone has become accustomed to decimal. That's easy to understand for binary. It is every 2 into 1. You will see that binary has only 0 and 1. Only 0 to 9 in decimal. That is, there are no 10 in decimal. Hexadecimal is no hexadecimal. There are no 2 in binary. So we will also talk about base conversion today. First of all, you need to know the 32-bit binary number is a format of an IP address. We can write it as 4 sets of decimal numbers. The largest single digit in a decimal number is 9. Everyone can see a total of 4 groups. 192, 168, 1 and 111. A total of 4 groups, separated by 3 dots. We refer to this format as dotted decimal. This is the composition of dotted decimal. So you will find formed so far. Conversion between binary and decimal. That is 32-bit binary number. It can be written as 4 sets of decimal numbers. This is a core transformation of it. For the number of digits, the value expressed by each number in each bit is different. Back to front. The later the number represents, the smaller the value. Everyone starts from the basics. For example, I write a 101. We calculate in decimal. It's called a bit. This is called 10. This is called the 100. Then everyone will find, in this bit, the 1 represents the 1. This 0 represents 0 times 10. And the 1 in this bit is 1 times 100. If it is 201. Here are 2 100. Everyone will find each digit if it is in a different number of digits. In fact, the values it represents are not the same. Followed by a small value. Large value in front. If a digit has no way to represent the current value. For example, now want to represent a 10 in decimal. But a single digit can only represent a maximum of 9. That now wants to mean that 10 can only go forward by 1. This one becomes 0. 1 step forward. 1 to represent 10. It's called decimal. That binary is the same thing. 1 bit of binary represents at most 1 0 or 1. How to express a 2 in binary? There is only one 1 in the single digit. If you want to express 2, you can only move forward by 1. Turn this bit into 0. Which one is taken as 1? It's called carry. These are what we call bases. The following are the rules of the base. Binary 0 and 1 in different bits. The meaning is also different. No matter which base. If a bit represents a value of 0. In fact, this 0 means that it will never take a value. Then if it is 1, it represents the value. Because it has only 2 variations per bit. 1 means that this person has. 0 means that this bit does not. And the information we express should correspond to different digits. To correspond to a different number of digits. For example, I want to express a 1 in binary. In fact, the decimal represents a 1. Now here comes the problem. What if I want to express a 2 in binary? Okay. 10. 'Cause I'm going 1 step forward. 10 is 2 in our decimal system. If a 3 is expressed in binary, the last bit is 0 plus 1. So it's 11. In decimal it represents 3. Because it's too slow to write them down one by one. So I just wrote it in multiples of 2. If a 4 is expressed in binary, because 11 represents a 3. So further forward you want to say 4 is 100. Now the difficulty level up. What if I now want to express an 8 in binary? Let's take a look. The last digit is 1. Represents that the value of this bit is 1. This 10 corresponds to. My bit value is 1. Stands for 2. So actually if there are 3 ones here, it stands for 7. If I want to express 8, I have to move forward 1 bit. It's 1000. Everyone will find. When we finish writing these now. In fact, we should write it more disciplined like this. That is, align the last bit. It will look more beautiful. You will also find that there is a rule in it. When the last bit is 1. Actually it stands for 1. When the second to last digit is 1. It stands for 2. When the third to last digit is 1. It represents 4. When the fourth to last digit is 1. It represents 8. So it stands to reason that if all 4 bits take the value of 1, then add the previous values, is equal to 15. So if I now want to express a 16, just add 1 to the original. We will find 1 plus 1. 1 plus 1. Then carry over. Recarry. Then it becomes 1 and 40s. Represents a 16. In fact, this is a conversion between the bases. 4 digits can only represent a maximum of 15. Then if I want to express 16, I can only go 1 step further. Now the 4 ones actually represent 8 plus 4 plus 2 plus 1. In fact, the maximum it can represent is 15. So I want to express 16 words. It must be 40s. Stands for 16. The rest can be pushed according to the rules. Then if 50s represents 32. If 60s represents 64. If it is 70 represents 128. You can do the math after class, according to the method I gave. Okay. Now I'll give you a different way of writing. Correspondence between binary and decimal. We might as well write, assuming that each bit takes a value of 1. We can convert these 1. When the last digit is taken as 1. Here it represents 1. This is the last. Then here are 2. Here are 4. Then go forward to 8. This table is derived from our previous calculation. A value of 1 in the last digit means 1. Corresponding to this bit is 1. If the first bit is 1, it corresponds to this 170. Stands for 128. In fact, everyone will find. We spent so long studying these 8 numbers. It's because these 8 numbers are very closely related to IP addresses. Each of our sets of decimal numbers can be represented by 8 binary numbers. In other words, 32 bits in binary equals 4 decimals. There is a conversion relationship. Actually, the IP address should have been 320101. The reason why it can be written as 192.168. Just because of this. Because all 8 binary can be expressed in decimal. Their lengths are exactly equivalent. Then let's study exactly how they are calculated. For example, what we just wrote. 192.168.1.111. So how exactly does it count as binary? Let's calculate together. Calculating this process is actually quite simple. I will simulate a scenario for you. This scene is quite interesting. Suppose I now draw a square. We divide it into 8 equal parts. These 8 equal parts correspond to the previous values. The top is 128. Then down to 64. 32. 16. We are now going to perform a calculation. Suppose compute 192.168.1.111. We're going to take a decimal number like this. Converted to a 32-bit binary number. We're going to do a transformation. Now we're going to convert it to 0101. You can also calculate it yourself. Can be hit on the screen. First, let's simulate a scenario. We call this kind of algorithm the number crunching method. This is the most basic method. We express each group in 8-bit binary. That is to say, 192 I want to take 8 binary representation. 168 I will also take 8 binary representation. I take 8 binary representations for each group. In the end I followed the order. Arrange it in order to get a result. Then I draw this shape on the left. It is to simulate a scene for you. Like you are now the boss of a company. Let's say you have 4 employees. 192 respectively. 168. 111. Say you want to give them some rewards. That for employees. You have some different handling mechanisms. If you do a good job, you will be rewarded more. For example, the first person does the best. You're going to buy it something for 192 bucks. Suppose these scenes on the left are something on the shelf. Cheaper and cheaper from top to bottom. So it's up to you to spend all your money. How much can you buy? Let's first calculate this 192. If I take this to buy 128. Can buy. 192 equals 128 plus 64. From top to bottom. Definitely pick the expensive ones first. When will the money be spent? 192 can definitely cover 128. So here it is set to 1. This bit must have a value of 1. Because 192 can cover 128. Equal to 64. 64 is exactly the price of the second thing. That's the equivalent of being able to afford this. So the value is 1. After buying 64. The following is 0. It's like the 2 most expensive things you've bought. Then you won't be able to buy them all. So it is equivalent to all take the value of 0. After we calculate such a value, we sort from top to bottom. 2160. Then it represents 192. Let's look down at this 168. First of all, 128 can be bought. 168 minus 128 equals 40. That 64 can't be bought. Then the value is 0. 32 is available. Value is 1. 16 can't buy it. Value is 0. 8 is just right to buy. Value is 1. After buying 8. After that, all values are 0. So the binary representation of 168 is 10101000. We won't talk about the third one. This one can only buy the bottom one. Then there are 7 zeros in front. We look at the last 111. First of all, 128 can't buy it. Value is 0. 111 minus 64 equals 47. Also equivalent to 64 is affordable. Value is 1. 32 can also afford. Value is 1. Then subtract 32 from 47. Equal to 15. 16 can't afford it. Value is 0. The sum of the following is exactly 15. So you can buy it later. All values are 1. So now the binary representation of 111 is 01101111. So now these 4 sets of numbers. Let's put them in order. We line it up. That's the equivalent of a 32-bit binary number now. Actually, it's not as difficult as you think. When many students first learn base conversion, always find binary and decimal conversions particularly difficult. That's because people are too lazy to do the math. If you think it's a little more difficult, then every time you count, you can list these numbers first. In fact, wait until you basically finish the whole stage. You'll be familiar with it soon. Okay. It's in decimal. Below is the binary. They are converted using such a method. If you think this method I'm talking about not very easy to understand, then you can find another way. I think this should be the easiest way to remember. That is, for now, the overall address expression is like this. So now I want to ask you another question. 32-bit binary. If I want to express it as a decimal IP address. So what is the maximum IP address? How small is the smallest? We can use a binary calculator. This calculator can be turned into a programmer's calculator. Programmer's calculator is binary from bottom to top. Octal, decimal, and hex. For example, in hexadecimal I write an A. Binary it is 1010. Represents a 10. 10 in decimal. In octal, every 8 in 1 is 12. Octal is not used much. What we use most now is binary, decimal, and hex. Hexadecimal is actually the same thing. As far as the NA stage is concerned, the most important thing is the conversion between binary and decimal. If you usually write a decimal, you're not sure how much. You can check it here. For example, we write a 192. Binary is 11000000. For example, write another 168. Binary is 10100000. Finally write a 111. Binary is 01101111. This is a calculator. Today we're going to talk about subnet masks. There is also a calculator for the subnet mask. Specifically to calculate it. We can see it later. So let's go back to that question. If the 32-bit binary is expressed as a decimal IP address, what is the maximum address that can be expressed? And what is the minimum address that can be expressed? Okay. For 255s and 40s. That is. For 32-bit. If all 32 bits are set to 0. Must be the smallest value. That is. For IP addresses. Current max and min. It's actually pretty well calculated. The smallest representation is all variable binary. Are set to 0. Actually 32 zeros. Every bit is 0. 0.0.0.0. The largest representation is all variable binary. Are set to 1. So what is the result of my calculation? The result is to add from 128 to 1. Is 255. Remember this number. 255.255.255.255. That is. One of the 32 bits of the final expression. Written in dotted decimal. Is 4255. You should know these too. This is what we call max and min. Everyone will find. Since IP addresses have a maximum. Have a minimal. That's actually 40 to 4255. This is the overall range of IP addresses. Then I will give you a simple question. Let's do the math. And this question. It is also related to the content of the next part. Let's take a look. 11000000. This is the first. 11100000. Then 11110000. 1 at the end 11110000. Now it's a binary. Let's calculate the corresponding relationship in decimal. Just add the first 2. Add the first 3. Add the first 4 bits. Add the first 5 digits. So let's do a quick calculation. 192.224.240.248. First of all, it must be correct. I want to ask you a question now. Is this an IPv4 address? Do you think this is a bit strange? I believe that it is difficult for everyone to see addresses in this format. Most of the students think it is not an IPv4 address. For our IP address. No matter how strange it looks. But it only needs to conform to the configuration format of the IP address. It is a correct IPv4 address. It is in the interval. And everyone is. It also does conform to the config format. So it's an IPv4 address. But you have to think about one more question. That means we are in the network. Can the IP address be assigned at will? We all know. Devices that want to communicate must have an IP. Then this IP is not as much as you want. It is indeed an IP address. But it is not particularly in line with our configuration habits. So what are our usual configuration habits? For IP addresses. There is a standardized organization in the world. Is dedicated to managing and assigning IP addresses. This organization is called IANA. It is an allocating authority for Internet addresses. It divides the entire IP address into 5 categories. Including your future study of IPv6 is also managed by this organization. Let's briefly summarize. Divided into 5 categories of ABCDE. Let's start with the first one. Class A address. For Class A addresses. 32 bits in total. Usually 32 bits are divided into 4 octets. We must first notice. First bit of first octet. Must be 0. That is. The first digit of 32 bits must be 0. I don't care what's behind. This format actually restricts only the first. It doesn't matter what happens after. The first bit must be set to 0. So now there is a new problem. If now the first digit of an address set to 0. So what is the current address? How big is the largest? How small is the smallest? First of all, How small is the smallest? The first value is 0. Then the last 31 are all 0. That is, minimum is 0.0.0.0. So what is the maximum? Okay. The maximum is from 127. Everybody can count. Since all values are now 1. Is 255. That first one represents 128. In fact, the maximum is the sum of the last 7 digits. There is no restriction on the number of digits in the rear. The last 31 digits are all 1s. Except for the first octet special. The back is 255. So in fact, the range it expresses is 4 255. That is, 3 255s are preceded by a 127. This is a range of it. So you will find Class A addresses actually define an interval range. Okay. We next look at Class B addresses. Class B addresses are actually similar to Class A addresses. It specifies the first 2 bits of the first octet. Must be 10. The minimum format is 128. The smallest is actually the first value of 1. The rest are all 0. The first value of 1 is 128. The last 7 digits are all 0. No value. Then the maximum is 255 minus 64. Is 191. Okay. Although no one has calculated the answer. But we all know how. In the end, this value is not the most important. We know what counts that counts. The above are Class B addresses. Let's move on to Class C addresses. For Class C, in fact it will have some of the same places. It specifies the first 3 bits of the first octet. Must be 110. So they are actually connected to each other. The minimum format of this format is that the first 2 digits are 11. Then everything after that is 0. That is, 250 minus 32 is 192. The biggest is 110 followed by 5 1s. Okay. Is 223. We have finished the ABC class addresses above. Actually, we're already halfway there. Let's stop. Let's not talk about Class D addresses. Because Class D is actually the same format. ABC 3 types of addresses we call them. Unicast address. For equipment, there are only 3 types of addresses in ABC. It can be configured on the interface of the device. Do you remember what unicast is? I mentioned some in the last lesson. When we communicate one-on-one, like the second floor, we are going to do data encapsulation. Then package. Layer 2 encapsulates source MAC and destination MAC. Layer 3 encapsulates source IP and destination IP. Then one device communicates with another device. We call it unicast. Only the 3 types of addresses ABC are called unicast addresses. It can be configured on the interface of the device. Or for terminal. Configured on the device's network card for identification. For equipment. When you go to address configuration, all configured addresses are ABC Class 3. This is called a unicast address. The remaining 2 categories are different from them. We mentioned it last class. Except for unicast. Also broadcast and multicast. Let's talk about multicast first. We didn't go into great detail before. Because at this stage we don't need to understand the whole multicast. This belongs to the knowledge of IE. I told you about the format of the MAC address before. A MAC address is a 48-bit binary number. We want to measure whether a MAC address is unicast or multicast. Depends on whether its 8th bit is 0 or 1. Then everyone should know. For the network layer, there is also a special segment in the IPv4 address for multicast services. So let's learn about Class D addresses now. Class D address. It looks from the format. Same as the others. Because it specifies the first 4 bits of the first octet. Must be 1110. So it doesn't actually change much in the format. Then its smallest representation is 224. The biggest thing is, all 32 bits except the 4th bit are 1. That is 239. This is the range of Class D addresses. But only when you learn IE. Access to the real multicast service will only come into contact with Class D addresses. Then for a Class D address, it also has its own characteristics. It has a very clear stipulation. A Class D address can only exist as a logical address. It cannot be configured as a real address. But only in logic. It cannot be configured on the interface of our device. We all know. The device interface needs to carry out 3-layer communication. Is to configure the IP address. The assigned address cannot be a Class D address. You can understand a logical address as a virtual address. Let's say we're going to send data. Can be sent to a virtual address. And other devices can receive information about this virtual address. We call it listening. But this address, it can't be paired with any one device. Everyone can understand. It is a logical address generated by simulation. Configuration is not allowed. Multicast is knowledge belonging to IE. Slightly harder. We can't get in touch at the moment. So we are actually the most important now is the first 3 categories. ABC class. That is unicast address. This is what we will configure in the future. The last one is a Class E address. For Class E addresses, it also has its own corresponding regulations. It specifies the first 4 bits of the first octet. Must be 1111. Its minimum is 240. The maximum is that all values are 1. Actually 4255. So you will find the minimum of Class A is 40S. The maximum of E is 4255. That actually divides the ABCDE 5 categories. Our address range is from 40s to 4255s. Class E addresses are also special. It is a reserved address. The reserved address we call the laboratory. It is used for military or scientific research to do some research. This address is sealed. Temporarily unavailable to anyone. We can now use only the above ABC 3 categories. That is to say, what can really be configured are the 3 of them. Class D addresses we can also use. But it will involve some applications and protocols. When adding groups in the future, different protocols use different multicast addresses, including different applications. The logical multicast addresses they use are also different. A dynamic routing protocol will be learned in NA, called OSPF. At this stage, a multicast address will be touched. Are 225.0.0.5 and 6. That's not our focus right now. In fact, everyone knows that OSPF will use multicast. We have now introduced 5 categories. Class E addresses are reserved. You can't use it. But we can use the ABC class address. Please pay attention. Although Class ABC addresses can be used, but not all addresses of the ABC class can be used. There are some special ones that cannot be used. Let me introduce to you 2 of the more special addresses. The special address is. It has other uses. The first one is 0.0.0.0. You have to remember. This is 40s. This address is not available. Not only 4 zeros are not available. From 0.0.0.0 to 0.0.0.255. You can't configure. Because it has other functions. At the routing level, It represents all addresses in the whole network. Can also be understood as any address. For example, in the future, you are going to access the internet. If you are going to visit various websites in the future, then every URL you visit, the destinations are actually all different. Any business we visit, it's actually an internet business. It's the operator's business. As long as you are online. In fact, it is the operator's network. Then you just need to hand the traffic to it. It's just to help us forward. That is, you don't need to care where exactly you're visiting. As soon as you receive a data, now use the public network to directly forward traffic to them. So now for all this traffic, we can use 4 zeros to represent. That is to say, we use 4 zeros to replace all addresses on the entire network. It is also called a default route. Second, it has another function. It also represents an address called unspecified. I'll just tell you this, because we can't get in touch now. In the future you will be in the stage of NP. Learn a protocol. DHCP. We now turn on the equipment. Configuring IP addresses on the internet. For example, now for my network card. I'm on wireless now. Everyone can see. I now want to surf the internet on this device. So you need an address. Then I am not manually configuring this address by myself. Is obtained automatically. In fact, the device is now running a protocol. DHCP. I do dynamic host configuration. For us, there is a DHCP server in our company. Come and configure the IP address for me. Then, during the entire configuration interaction process, when the device runs this protocol with a server, I want it to give me the address. I have to send a package to tell it first. Communication of what we call data. In fact, the point is that the data comes and goes. I want to request some business. Request some parameters. I can send it in the form of a message. Like communicating with people. Device-to-device communication can only send messages. Then when I request the address, need to package. Data is encapsulated. For data communication, the parameters of each layer must be encapsulated. Even if you don't know. Also fill in a don't know. This field cannot be left blank. For the link, packets are actually bit streams. It's actually what we call an electrical signal. High and low frequency is the electrical signal transmitted. If fiber is used in the future, it transmits light signals. The data transmitted by the refraction of light inside. After being compiled by the network card, it becomes 0101. When you learn NP in the future, we'll learn something. Port mirroring. When you are in the project, when actually capturing packets, you can use port mirroring. Get the real message. For example, now this is a device. There are multiple interfaces on the device. For the interface, it always transmits electrical signals to the outside world. Then we can use another port. To enable port mirroring, you can capture the data that is actually sent so far. In the future, we are in the process of experimental configuration. I can show you. For running such a protocol, the first time you request an address from the outside world. Package address. Since you don't have an IP configured now, so you don't know what IP you are, you'll go with 4 zeros. Okay. This is the first special address. 4 zeros although belong to Class A address, but cannot configure. This is rather special. The second special one is 127.0.0.0. It refers to the entire network segment of 127 has been extended to 127.255.255.255. It's called a loopback address. We all know 127 is for testing. For example, test the network card is not bad. Or the test network is not working. If you think there is something wrong with the device right now, there may be a problem with the internet. If you want to test now, everyone will choose to open CMD to ping Google. Won't open CMD to ping a 127. This means that we routinely test network connectivity. In fact, there are many reasons for the failure of the real network card. Why we ping Google? Just want to see if Google will give me back the package now. I want to see if I can access the internet now. That's for 127. It is used to test the TCP/IP protocol station inside the device. I believe that everyone must not understand. Let's go back to the picture we just made. You can see an internet here. Write a TCP/IPv4 behind. This is a protocol station that has been integrated on the device now. I told you in the last class. The network communication model we are actually using now is a model like TCP/IP. Why we talk about OSI? Because it is more clearly divided into layers. Actually, although it is clearly divided into levels. However, due to the inexperience of this organization, not many protocols have been developed. An organizational framework that supports it. And for TCP/IP, it actually has a longer history. Developed earlier. And for every layer of internet communication, it has developed a corresponding agreement for. So, that's why we use TCP/IP now. What we see now is this TCP/IPv4. This is the device itself that comes with the Windows system later. Or called an integrated protocol. This protocol does not require you to manually install. But in the early days of the internet there were a lot of protocols. For example, Apple Talk, IPX and more. If you want to install such a protocol at that time, after the installation is complete, you need to test whether the installation is successful. Ping 127.0.0.1. If the ping is successful, it means the test is complete. Because only TCP/IPv4 can recognize such an address. If we fully use TCP/IPv6 in the future, that is, V6 doesn't know the address of V4 at all. Device is not recognized. If you install an IPX protocol, overall its address will be longer. Will be longer than an IPv4 address. Although it is compiled, it is also 0101. But their final representation, not dotted decimal, not 4 groups. If you install the IPX protocol, then you go to ping this address. Even if you call up the CMD command line, you use this ping. First of all, it doesn't know what ping is. Second, you ping an address like this. Definitely can't ping. Because this address does not conform to the protocol specification at all. It cannot be read. So you can see that there is an installation here. Click to install. Here is an option for a protocol. Can choose. You can click to add. But it's gone now. This is something we rarely use. But for the early, we will still install the protocol station manually. Because there is only one protocol station in the world now. No need to install. Because a network device is bought by default. Just to communicate. You can only choose this one if you want to communicate. Because all network devices only support TCP/IP. So now, by default, we also don't need to install any protocol. The difference between V4 and V6 is that the first point is the address space. IPv4 is 32-bit. IPv6 is 128 bits. IPv6 headers are more compact. Takes up less space. Implemented more functions. made a comprehensive expansion on the entire IPv4. In fact, the first problem to be solved is the number of addresses. In the future, if it can fully migrate to the state of IPv6. In fact, there is no distinction between public and private networks. This concept we will discuss next. Then we'll be a lot easier than we are now. This is only from the address direction. Second, due to the overall scalability of IPv6, it's in a lot of future features. More support than IPv4, including IPv6+ in recent years. SRv6. This is the future trend, due to the rapid advancement of IPv6 technology. So in recent years, IPv6 has been mentioned more and more. But in fact IPv6 has been around for a long time. But in recent years, the demand for it has become more and more strong. The above is to test the TCP/IP protocol station. When you have installed TCP/IPv4, you go to ping 127. No matter which address on the 127 network segment you are pinging. Ping from point 1 all the way back. Can be pinged. It tests the underlying protocol. So you will find, although the ABC class address can now be configured, but actually there aren't that many addresses available. Class A addresses are available from 1 to 126. You need to remember this. Okay. Let's go on. We have already divided the three types of ABC addresses. Well, I now have a new question. If I were to now have access to all the devices in the world, assign an address. According to reason, everyone must have an IP. Because if there is no IP, data packets cannot be encapsulated. Can't get online. Internet access with IP. Every device that wants to access the internet must have an IP. Then please. These IP addresses we now call. Is it enough to give each person one? Okay. Definitely not enough. First we need to know. The IP address is 32 bits in total. 32 bits have two variations for each bit. A total of about 4.294 billion changes. Then think about it. Is it enough to distribute to the whole world? We don't have only one mobile phone to surf the internet now. Generally speaking. Working. At least one laptop for office. Play games at home with a desktop computer. You have a computer, a cell phone, and a tablet. Each of your parents has a cell phone. Suppose there are 5 people in a family. Will occupy almost 10 addresses, including at home and now. Smart speakers or smart sweeping robots. Or the TV can also be connected to the internet. All these addresses add up. I believe you can imagine how many. For netizens all over the world, one address per person is definitely not enough. According to our logic. Wouldn't this collapse? If you want to go online, you need an address. Not enough addresses. How did you get on the internet? So there must be a way to fix it. That for the entire address design, we envisage. Because there may not be enough addresses. Therefore, in the overall address classification, we have divided into 2 categories. They are called private address and public address respectively. That is, based on application, split into public and private networks. So let's first talk about the public address. We want to communicate on the internet. All addresses under the public network when communicating must be unique. For example, your company is now running a business. Then your company is on the whole network. Is the only device that needs to be able to locate you. Your company has an export facility. Like Google. Google has a server. Then you want to access Google server. It can't be said that the Google server has a duplicate IP address with another place. When you visit, Who among them was visited? Also unknown. So we face the public network. We want all addresses. Must be unique. The public address has such uniqueness. I can access the entire network. That is, in the internet as a whole. I can only locate your device. Its uniqueness is based on worldwide uniqueness. That is to say, worldwide. It is guaranteed to be unique. But usually, you have to pay for this stuff. You need to spend money to find the operator to handle the corresponding service. Then the corresponding public address will be given to you. So we will know. Due to too few addresses. So it is impossible to guarantee. Every device in the world. Every interface. Use a public network. Definitely not enough. Suppose your company has 100 people. Need to apply for 100 official website addresses. For the time being. Let's not say whether the address is enough or not. The cost is already very high. Because it costs money. So, now we are going online. What each end user actually uses. Not a real public address. Instead use a private address. It is actually from the overall address space. Cut out a small piece. As a private address. Private address and public address are relative. It's not the only. This means that all network-wide can be used arbitrarily. It is free. And you don't need to apply. It is reusable. This is called a private address. Now above this is the operator. Below is the carrier's network. Services it provides us with access to. There are also many devices in the operator. And they are also connected. The address they use is the public address. Because operators want to provide mutual access services around the world. That is to say, all forwarding addresses on the public internet must be determined. Can uniquely locate the next device. Because you have to keep querying the next device. Forward. It is absolutely impossible to appear in the middle. Two addresses are the same. Certainly. It's not absolute. Later you will find out. It's not as simple as what we're learning now. But you can understand this now. Public network. The operator's network is the public address. Of course it also has a private network. But the specific operation and enterprise network are not a set of operation model. Therefore, there will be a special technical direction in the future. Is operator technology. Then you will find. It is not a technical system with the enterprise network. So for us now. You can remember this. The above is the public network. Then export this device. When docking with operator equipment. This address must also be a public address. Because the company's people are going out to the internet. Then the package needs to be returned to the device. Otherwise there is nowhere to find the message. I can't pack it back. So it has to be a public network too. But for the following. Such a network range. There are multiple users inside. Then these users can use the private address. This is the address that every company can use. The future is exporting here. It will do a conversion between the private network and the public network. Now only guarantee. This private address is not repeated internally. Because now there is internal communication. Can't share the same name with other people. But in the future when we export, a technique called NAT can be used. Put this through a conversion. Convert this private address to a public address. Then go out and go online. After the network finally responded. Then configure the NAT device by this. Convert this address to a private address. That is to say, this is equivalent to the internal and external network. It's two completely different systems. We can use private addresses internally. When people are online. transfer to an external public network together. Then it goes to the public network. So then, since every unit, every organization and institution can be used internally, but it won't repeat. For example, we can all use 192.168.1.1. Every household has this address. Why not repeat? Because when we finally access the public network, the converted address is a public address. It will not repeat. But within each organization, the private address used is randomly repeated. Because they do not communicate, even if there is a need for mutual visits in the future. That is also the demand from the public network to the public network. Because only the final data traffic reached the peer device. It only knows that the NAT is going down now. Actually, we all access the public network from the public network. That's how we look. At least from the looks of it. Then inside, we do such a conversion between technologies. Unlimited things can be done with limited addresses. You will find that your company originally 100 people occupy 100 addresses alone. It's different now. Can now be allocated 100 addresses available to all companies. Equivalent to the end user problem solved. We only need to ensure that the current public address, when the user comes out, it can be converted smoothly. What we actually use now. Such a technology. If the current Google address is 7.7.7.7, it has a mask that is 24 bits. Then can I configure a 7.7.7.7 for the internal device now? Okay. This address is configurable. The reasons are as follows. First, it conforms to the configuration specification for IP addresses. It must be connected to the device interface. Second, for example, you assign 0.6 to the one on the left. This is 0.5. This gateway is 0.1. 7.7.7.1. There is no problem with communication between you. If the current public address is 123.11.2.3, there is no problem. After you have allocated this address now, it will be a rather embarrassing thing. Due to your current address and Google's address. Then when you encapsulate the data, by default, it will consider this to be an address on the same network segment. How are you sending the package now? The source IP is yourself. The destination IP is also your own. The source IP is the same as the destination IP. This message is in terms of the entire communication format. Is not possible. That is, I want to send myself a package. Then the default package will not send out the interface of this device. Because once this interface is assigned an address, that is, once configured with 7.7.7.7, a message will appear on your device. 32-bit host routing. Generated on your device. Because the device thinks this is you. To visit yourself. So it will not outsource. This is the first question. The second question is, if your address is weighted, does not affect the internal communication between you and others. Intranet is accessible. But this 7.7.7.6 on the left, when it wants to visit, source IP is self. The destination IP is 7.7.7.7. It wants to access Google. But since now when visiting, this device is computed locally, we will find that this person is on the same network segment as me. It thinks we're both on the same network. So it is directly communicated internally. It will send the data directly to you. It doesn't know I'm going to visit Google now. Because I am on the same network segment as Google. I thought we were on the same network. On a logical link. I'll just send it to Google. Google got it. That for you now. I can't go online. But that's not to say it's absolutely impossible. If now Google is not 7.7, it is 11.1.1.1. This is also a public address. But you are still using 7.7. That's fine. Such a public address can still be used internally. Now everyone can communicate with it. Because of the exit, this will convert the address to 123 of the exit. It's okay. But make sure. Internally. If a public address is configured, you have no way to access the future URLs on the same network segment as you. That is address conflict URL. Second, all other equipment. As long as there is a need to access the outside world, then it is inaccessible. You can configure, but you can't guarantee. Will this configuration affect other people's internet access? Because we are online now, DNS is used. We are all analyzing. You don't even know the destination server you are accessing now. Which network segment does it belong to? You can't promise yourself not to repeat it. That's why we can configure it. Can also pass. But why it is not recommended to do so? Some students will ask. Why does the configuration of the private network not repeat? Because it is absolutely impossible for a private IP to appear on the public network. That's why it made this painting a private network. It is specially designed for you to configure in the private network. Can guarantee you absolutely access to the public network. There is no problem. Because it can guarantee. There is absolutely no device on the public network that will configure a private address. You can configure it like this. Then the DNS needs to be changed accordingly. Because for internet devices, just such an address. First, make sure other devices can't think the server is you. Second, for external devices, except in your internet, no one knows you are at this address. So can you configure this? It doesn't matter to the outside world. You just have to guarantee. There is no internal conflict. Because to the outside world, now this is an internal. No one cares who this is. In the end, we are all going to perform NAT. That is, when we connect to the carrier, one address is enough. It can meet the current needs of internal internet access. Then, for the private address, it has a stipulation. That is, range of private addresses. Everyone will find. I am from the ABC 3 types of addresses. Cut out a piece. As private address. Everyone can see. First of all, the first one belongs to the Class A address. From 0 to 127. The second is to cut out a block in the B class address. Because Class B addresses are from 128 to 191. It is 172. And a block is also cut out from the Class C address. In fact, these 3 types of private addresses, it is possible to distinguish small, medium, and large corporations. Generally for small businesses, Class C address segment is sufficient. For medium-sized companies, if Class C is not enough, use it together with Class B and Class C. Large enterprises directly use Category A. You will find it more variable in number. Class C address segment can be changed to a smaller range by default. So let's summarize the 3 types of ABC addresses. Looks like we can all use. But actually on the internet. That is, when we are going to network, we really have a unique IP address on the public network. You want to remove the special address. And remove the private address. Because private addresses are generally used by internet users. Not available on public internet. So you have to rule out the private address. The rest is what can really be configured on the interface. Unique IP address. Next we have to mention another concept. Subnet mask. For the IP address we just talked about, the following is suffixed with a subnet mask. Why is there such a suffix? Everyone can see. When I was showing the network card just now, this IP address has a subnet mask under it. There is a correspondence between them. Let's see how they look first. The first to discover. They seem to be similar. Both are dotted decimal. So let me ask you a question now. For example, now there are two devices. Each device is configured with an IP. Can they communicate? For example, this device is configured with 192.168.2.3. Another device configuration 192.168. 1.2. Can they communicate directly? Okay. It depends on the mask. You want to know if you can get through. You can't tell just by looking at the address. We have to combine another parameter. Mask. Because it is possible to communicate directly. This is to have a network segment division. You may have heard a sentence. Direct communication on the same network segment. Different network segments cannot communicate directly. So we can't just look at the address. Let's look at the network segment. So we have to combine another parameter. Subnet mask. Only after combining the subnet mask, the classification of IP addresses has the greatest significance. It can constitute all the information used on a real network card. After IP address classification, 3 ABCs actually define different address ranges. That is, subnet mask. Then I will add to you. For class ABC, in addition to defining their current value, they also define their respective masks. The mask of class A is 255.0.0.0. That is to say, class A address defaults to a 8-bit mask. That's the same for the BC class. The class B address mask is 255.255.0.0. It defaults to a 16-bit mask. The class C address mask is 255.255.255.0. It defaults to a 24-bit mask. This is the default. I will give you a simple demonstration. For example, I'm going to be on my NIC now. Go configure it. This address is supposed to be automatically assigned. I now want to manually write an address to it. Let's first write a class A. For class A, we will write according to the private address. Now let's say we're configuring the address right now. I am writing a 10.1.1.1 here now. Watch carefully. I do not configure the mask. Just hit the tab key. Make it wrap. Everyone will find. It automatically adds 255.0.0.0. Because what I'm writing now is a class A address. Although it is a private address. But it automatically writes me a mask. For example, I write a class B address. 172.16.1.10. Hit the tab key and you will find. I have to delete this first. Everyone can see. It automatically fills me with 2255. I will now write another class C address. 192.168.1.12. Let's not click OK now. Because I don't have a gateway configured right now. If I now change the overall address and gateway, I'm disconnected now. Because I am using a default assigned address. And after I change the address, may conflict with other equipment in the company. After I hit the tab key now, everyone will see. 3 255s are now filled by default. This is equivalent to, for such an address, our equipment will automatically identify which address range it belongs to. It stands to reason. This 192.168.0.02 192.168.255.255. By default it belongs to the address range of class C. And the mask is 24 bits. Then when you configure a class C address on the device, it will automatically match your mask. We call it classed. It is divided into ABC3 categories. So for the address, it must be seen in conjunction with the mask to make sense. The subnet mask can define two parameters. It can define parameters of network bits and host bit parameters. This is what it does. We use a form of IP address plus mask. You can define a range of network segments. Then after defining the network segment, direct communication between the same network segment. No direct communication between different network segments. How to define it?